Good day, and welcome to this presentation. Today, we'll be delving into a crucial aspect of the SF-260FH, M aircraft, its landing gear and brake system. Understanding these systems is vital for safe and effective aircraft operation and maintenance. Throughout this presentation, we will cover the description and operation of the main landing gear, the nose landing gear, the extension and retraction systems, the hydraulic brake system, and finally, the wheel assembly. Our primary reference for this information is the SF-260FH-2 Maintenance Manual, Chapter 32. Let's begin by looking at the landing gear itself. The landing gear of SF-260FH-M aircraft is equipped with a tricycle, electrically retractable type landing gear. This design provides stability during ground operations and allows the gear to be stowed for improved aerodynamics during flight. Main landing gear. The main landing gears are robustly mounted on support fittings within the wings, specifically on the wing spars. Each main gear assembly is comprehensive, consisting of a wheel and brake attached to an axle assembly, a shock absorber, and a supporting leg. Shock strut absorber. A key component of the main landing gear is the shock strut absorber, which is of the oleo-pneumatic type. This means it utilizes both oil, oleo, and compressed air or gas pneumatic to efficiently absorb landing and ground shocks, providing a smoother ride and protecting the aircraft structure. For the SF-260FH model, this absorber is serviced with hydraulic fluid and 669 psi of nitrogen. For the SF-260M model, it uses hydraulic fluid and 682 psi of nitrogen. The shock strut absorber primarily consists of a piston bearing a metering valve, an orifice plate, O-rings and packings, and an outer cylinder. Nose landing gear. Moving to the front of the aircraft, the nose landing gear of the SF-260 is designed as a leg and fork type. It incorporates a coaxial shock absorber and a torque strut for stability and steering control. Like the main gear, the nose landing gear shock absorber is also of the oleo-pneumatic type. For the SF-260FH, it is serviced with hydraulic fluid and 157 psi of nitrogen, while for the SF-260M, it uses hydraulic fluid and 143 psi of nitrogen. Its core components include a piston, a spacer, a piston bearing a metering valve, an orifice plate, and a cylinder. A practical feature of the nose landing gear is that nose wheel steering is precisely accomplished by using the aircraft's rudder pedals in the cockpit. Extension and retraction of landing gears. The system responsible for moving the landing gear is designed to efficiently extend and retract the gear, and, crucially, to retain it securely in the up-locked position during flight. The key components of this system include the electric actuator, which provides the power for movement, the main bell crank and bell crank control rods, which transmit motion, the drag braces, which provide structural support and assist in locking the gear, and the comprehensive electrical control circuit that manages the entire operation. In addition to the normal electrical extension, an emergency gear extension system is also provided for safety. This system is controlled manually by a hand crank conveniently located in the cockpit. Hydraulic brake system. Now, let's turn our attention to the critical hydraulic brake system, which ensures effective stopping power on the ground. This system integrates several key components: a reservoir for hydraulic fluid storage, master cylinder assemblies that convert pedal input into hydraulic pressure, parking brake valves for holding brake pressure, all the relevant lines that route the hydraulic fluid, and the brake assemblies themselves at the wheels. Reservoir. The hydraulic fluid reservoir is strategically installed at the left front of the firewall. Its primary function is to serve as the storage for the aircraft's hydraulic fluid, ensuring a constant supply to the brake system. Master brake cylinders. Brake actuation is hydraulic, achieved through a master brake cylinder connected to each rudder pedal. For dual control, the master cylinders at both the pilot and CO pilot positions are connected in series, allowing either pilot to control the brakes. parking brake valve. A parking brake valve is incorporated into the brake system, located below the cockpit floor on the left side. When manually operated, it effectively prevents the return of hydraulic fluid pressure after the brakes have been applied, thus keeping the brakes engaged. This valve is controlled by the parking brake control assembly, also on the left side. To operate the parking brake, 1. First, press the rudder pedals to apply the brakes. 2. Then, pull out and turn the parking brake handle 90 degrees clockwise or counterclockwise. This action closes the parking brake valve, which then retains the pressure in the brake lines. To release the parking brake, simply turn the handle and push it back in. Brakes. The main landing gear wheels of the SF-260 are equipped with reliable disc-type brakes. Brake assembly. Each brake assembly consists of several important parts: the cylinder body, the piston, the pressure plate, and the linings, which are riveted to the pressure plate and the back plates. The cylinder body also includes a bleeder valve and a union, which allows for the connection of the hydraulic fluid line. Braking action. The braking action itself is produced by applying pressure to the rudder pedals. This pedal input causes hydraulic fluid to be drawn from the reservoir and pressurized into the brake cylinders. This pressure then forces the brake linings against the rotating disc, creating friction and slowing the aircraft. Wheels and wheel assembly. Let's look at the wheels that support the aircraft on the ground. Main gear wheel. The main gear wheel is of the divided type, a design that greatly facilitates tire installation and removal. It consists of 2 hub halves in the brake disc, all securely held together with bolts, washers, and self-locking nuts. These hub halves are precision machined from magnesium alloy casting, providing both strength and lightness. The wheel rotates smoothly on tapered roller bearings. Main gear tire. The tire installed on the main landing gear wheel is a 6-6, 6PR type, and it is provided with an inner tube. For proper inflation, it is serviced with 55 psi of compressed air or nitrogen. Nose gear wheel. Similar to the main gear wheel, the nose gear wheel is also of the divided type for easy tire maintenance. Its 2 cast magnesium wheel halves are held together by bolts, washers, and self-locking nuts. These hub halves are also machined from magnesium alloy casting, and the wheel rotates on tapered roller bearings. Nose gear tire. The tire installed on the nose gear wheel is a 5-5, 6PR type, also provided with an inner tube. This tire is serviced with 50 psi of compressed air or nitrogen, hydraulic fluid, and grease. The aircraft systems rely on specific fluids for optimal performance. Hydraulic fluid. The hydraulic fluid used is MIL-PRF 5606 hours. This is a mineral oil-based super clean hydraulic fluid specifically designed for brake and hydraulic systems. It is easily identifiable by its red color. Being a kerosene petroleum product, it possesses excellent lubricating properties and includes additives to inhibit foaming and prevent corrosion within the system. Grease. For lubrication, Aeroshell Grease 6 is used. This is a general-purpose airframe grease that is inhibited against corrosion and oxidation. It stands out for its outstanding low-temperature torque properties and resistance to water, making it suitable for a wide range of conditions. Its useful temperature range spans from 40 degrees Celsius to plus 121 degrees Celsius. It's primarily used in plane and anti-friction bearings on general aviation aircraft. Disc and brake lining limitations. For safety and performance, there are specific limitations regarding the wear of brake components. The minimum allowable thickness for a brake disc is 0.5 inches, or 8.76 millimeters. For reference, a new brake disc has a thickness of 0.4 inches, or 10.16 millimeters. Brake linings should be replaced when they are worn to a minimum thickness of 3/32 inch, or 0.1 inches, 2.8 millimeters. A new brake lining for comparison has a thickness of 0.02 to 5.6 millimeters. Adhering to these limits ensures effective braking and safety. Conclusion. We've now completed our detailed overview of the landing gear and brake system of the SF-260 FHM. We've covered the components and operation of the main and nose landing gears, how they extend and retract, the intricacies of the hydraulic brake system, and the details of the wheel assemblies. We also discussed the specific hydraulic fluid and grease used, along with critical wear limits for brake components. Understanding these systems is fundamental to the safe operation and maintenance of the SF-260 FHM aircraft. Thank you for your attention, and I hope this presentation has been informative. Have a safe flight.